Hi, we are starting Module 4 today for Math 2, and we're looking at more functions and more features. So go ahead, get your module packet ready, and we are going to skip ahead to page 5, and we're starting right here at section 4.1, some of this, some of that. And we're starting looking at this graph down here. And we're going to be looking at a graph that demonstrates the number of tourists in thousands at a resort in Florida in the weeks after April 1st. We're going to describe each section as it relates to the situation. So down here on the bottom, we have weeks after April 1st. So here's like April 1st, and then here's 1 week after that, 2 weeks after that, 3 weeks after that, 4 weeks, 5 weeks, etc. So here would be 5 weeks, 6, 7, 8, 9, 10 weeks. And then there's 15 weeks. Okay. So when we're starting to look at this, we see that as during the beginning part of April, as time goes on, the weeks go on, we start getting more and more tourists arriving in Florida. Why do you think that might be? What goes on in March and April? Spring break. So this is like April. Okay. Now, after about 5 weeks or so, we see that the number of tourists remains about the same. It remains constant. Why? What happens in about May? Spring break still going on? No. But are other people still there? Maybe it's good fishing season, something like that. So this section, the kids are back in school. But the fishermen are still there. Perhaps. All right, April, May, so about 10 to 15 weeks after, we're starting to talk about June and July. Oh, look at the number of tourists now, steadily increasing. Much faster. It's a steeper slope here, so at a steeper rate, so faster than in early April. Why? What's going on in June and July? Yeah, people are on vacation. Okay. All right, here's August. All right, what happens in August? The number of tourists declining because kids are going back to school. Okay, now we have this graph. We're going to ask a bunch of questions about it on the next page, so we're going to have to flip back and forth a bit. So please be aware of that. I'm going to be flipping pages back and forth to looking at it. All right, so this first question here, look back at the graph for number 1. How many pieces or sections do you see? So if we look back, how many sections do you see? Yeah, there's 4. There are 4 sections. And does this graph represent a function? Oops, can't see what I wrote, sorry. 4 sections. Does the graph represent a function? So here's the graph again. And remember this test? Vertical line test. Can you pass a vertical line and only hit one point on the graph at a time? Absolutely. So this is a function. Does this graph represent a function? Yes, because it passes the vertical line test. Okay, when we have something that looks like this, we have all these sections, if you will. It's called a piecewise defined function. A piecewise defined function is a function that is defined by 2 or more sub-functions or pieces of functions, with each section existing only in a certain interval of the domain. So they don't overlap, if you will. All right. When you write a piecewise defined function, we have f of x here, but we've got those 4 pieces. And on this beginning part, that's where you're going to write the function. Function goes here, and the domain values go here. So let's look at that very first section right here. This first section, definitely a line, and we see that it has a y-intercept of 0. So it's hitting right here at 0, 0, crosses the y-axis at 0. And if we can count slope, up 1 over 1, up 1 over 1, up 1 over 1, up 1 over 1. So slope is 1. That's just 1x. There's your slope, x plus the y-intercept. You could just write that as y equals x. Slope, y-intercept. I am going to pull these off here because I want it to be kind of clean. So y equals x. Now, what x value is that valid for? Well, that's valid from x is 0 all the way up until there, and that's at x equals 5. So we'll say this is valid for x between 0 and 5. And visually, do you see x sitting in between the 0 and 5? Okay, looking at this next piece, this one right here, that is a line. It's a horizontal line, and the y values of that line are remaining constant at a constant height of 5. So this function is 5. Now, when is that one valid? So for what x values? Well, it starts there at 5, and it stops at 10. So this function will be valid, or x is between 5 and 10. Now, notice I put an open thing here, strictly less than. I can't put an equal sign here because I already have 5 defined up there. So I can't have 5 defined in 2 separate places. This one goes all the way up to and including 5. This one starts just after 5. So if this is closed up there, less than or equal to, this one has to be open or strictly less than down here. Looking at that next section. All right, well, clearly a line again. I can't see a y-intercept, but I can count slope. So up 2 over 1, up 2 over 1, 2 over 1. So slope is 2. Definitely this then has to be 2x. Now, I got to figure out what that y-intercept should be. I know that this point is going to work, 10, 5. So I'm going to come over here to the side, and I'm going to say y equals 2x plus something. I'm going to figure that out. That, whoops, can you see? Yeah, that b. And I know that the point 10, 5 will work. So I'm going to plug the 10 in for the x and the 5 in for the y. 5 equals 2 times 10 plus a b, and I'm trying to figure out what that number is. This is 5 equals 20 plus b. And if you subtract that 20 from both sides, you'll get b is negative 15. So that means that this is 2x minus 15. If that's tough for you, we're going to do another one in a minute. So hold on a second, and we'll redo another one. Let's look back over here, and let's see if we can find the domain values. Where does that one start? It starts at 10, and it stops at right there, up at 15. So again, 10 is used up here, so it's got to be a less than here. And we're going to send this all the way up to 15. All right, let's look at the last section. Again, start off counting slope. Down 1 over 1, down 1 over 1, down 1 to the right 1, down 1 to the right 1. So that slope is negative 1 over 1, or just negative 1x. All right, let's see if we can figure out what that y-intercept is going to be over here. I'm going to do it over here on this one. Right now I have y equals negative 1x plus some y-intercept, and I'm trying to figure that out. I need a point that's going to work. There, how about that one? 15, 15. So I know that 15, 15 works. So I'm going to plug 15 in for x and 15 in for y. So we have 15 equals negative 15 plus b. Add 15 to both sides, and b is 30. There's your y-intercept, plus 30. Okay? All right, we just need the domain for that last one. So again, we look. What x values is that graph valid for? It started at 15. And it stops out here at this one. Let's see, what was that? Here's 15, 16, 17, 18, 19, 20. That goes up to 20. And there is a piecewise defined function. So we have all of these individual pieces, functions, and the x values for which those pieces are valid. Excuse me. Okay, now, so let's look at some more problems here. Oops, wrong way. There we go. Which subfunction or which piece would you use to algebraically find the value of f of 12? Well, if we wanted to find f of 12, that's the x value. So I have to go up here and I have to look in the domain and figure out which section would you plug 12 into. And 12 goes into this middle section right here, this blue one. between 10, x is between 10 and 15, so 12 is between 10 and 15. So which subfunction we would use f of x equals 2 times 12 minus 15. Oops, I should have said which piece. I should have written an x here, I'm sorry. F of x equals the 2x minus 15. Now find f of 12. So 2 times 12 minus 15, which is 24 minus 15, or 9. So let's go back to the graph and see if that matches. When we plugged in x equals 12, 11, 12, do we get 9? Okay, I'm going to follow 12 up till it hits the graph. Right there. Let me take that across. Oh yeah, 9. Perfect. Okay. Oh, and what is f of 12? There's f of 12, right there, 9. Okay, same idea. Let's find each of the following. F of 7. So which piece does the 7 fall in? Which section? It falls in right here. 7 is between 5 and 10, so we'll go over to the function, and that function is 5. No matter what number you choose between 5 and 10, you're going to get a of it. Done. F of 15. Which piece does that go into? This blue one or the orange one? Well, this one, because it's exactly 15. This one's bigger than 15. This one is exactly 15, so I'm going to go into this middle one. So that's going to be 2 times 15 minus 15, or 30 minus 15, which is 15. Now, these guys are trickier. You have to use the graph for these guys. I want you to find x when f of x is equal to 3. So this is find x when y equals 3. Go back to my graph. Y equals 3. Y is 3 is right here. So I'm going to take that over. What's the x value that produced that y value? Oh, it's the same thing. It's 3. So that happens when x equals 3. Let's look at this next one. Find x when f of x equals 13. So when y equals 13, here we go. Y is 13. Let's follow that over to where does it hit the graph? Hits right there, and that is happening at x equals 14. Oh, but wait, because x equals 13 hit there, but it also hits here. So what's this x value at this point? That's 15, 16, 17. So f of x is equal to 13 when x equals 14 or when x equals 17. So it had 2 of them. These guys, you have to use the graph. You must use the graph for those 2. Okay? All right, let's look at the next page. All right, so again, MVP is famous for reviewing things from previous math classes. And so that's what the rest of this module is, or the rest of the notes then are reviewing some topics from Math 1, and then some things that we've done here a little bit of. All right, we're going to talk about forms of lines. We have slope-intercept form, y equals mx plus b, where m is slope and b is the y-intercept. Standard form, ax plus by equals c. This one is very nice if you want the x and y intercepts. We've done that this year, and I believe it's called the cover-up method. Do you remember when you covered up part of it and then solved for y, or covered up this piece and solved for x? And the last one, point slope, my favorite. Y minus y sub 1 equals m times x minus x sub 1. M, still slope. And this, y sub 1, x sub 1, x sub 1, y sub 1 is any point on the line. Looking through some examples here, I want you to write the equation of each line in point slope form. So we're starting with this form up here that's just off the screen. There it is. Y minus y sub 1 equals m times x minus x sub 1. So I'm going to start first. Y minus y sub 1 equals m times x minus x sub 1. I'm writing the formula, and then I'm going to fill in the stuff I know. The point is 2, 7. So here's y minus the y value of the point, 7, equals slope 4 times x minus the x value of the point, 2. That's it. Done. Nothing to rearrange, nothing to simplify. That's it. Look at this one. Filling in again. Y minus y sub 1 equals m times x minus x sub 1. Y minus the y value of the point. Y minus a negative 2. What happens there? Turns to plus a positive. Equals slope 1/2 times x minus the x value of the point, 3. That's it. Pause the video for a moment. You guys try this one on your own. Seriously, pause the video and you guys do this one. Then turn it back on. Thank you for coming back and pausing the video, trying this on your own. Let's see if we end up with the same answer. I got y plus 7 is negative 5/2 times x plus 5. Hopefully you ended up with the same thing. If you did not end up with the same thing, then you're going to have to ask one of your teachers at the next day of class. Look at this next one. Oh boy, they gave us 2 points this time, but they didn't give us the slope. Well, you're going to have to figure out the slope first. So slope, do you remember the formula? Is y2 minus y sub 1 all over x sub 2 minus x sub 1. So using these points, we're going to subtract the y's. 12 minus 8. Subtract the x's in the same order that you subtracted the y's. 12 minus 8, 5 minus 3. That simplifies down to be 4 over 2, which is 2. That's your slope. Now substitute into point slope form of a line. And you have 2 points. You can pick any one you want. I'm going to use this one. So I'm going to do y minus the y coordinate, 8, equals slope 2 times x minus the x-coordinate of that point, 3. Now, maybe you wanted to choose the other point. If you choose the other point, it would have been y minus 12 equals 2 times x minus 5. They look very different, but they are actually equivalent. If you were to distribute this 2 through, and then move the 8 over, distribute the 2 through down here, move the 12 over, you would get the same answer. Either, you don't have to give both, either one of those is correct. Over here, again, given 2 points, you need to find the slope first. I'm going to subtract the y's. Whatever order you subtract the y's, you got to subtract the x's. I'm going to do negative 4 minus 7 over 9 minus negative 3. Be very careful there. 9 minus negative 3, which gives me negative 11 over 12. Ugly slope, but that's the slope nonetheless. Now just plug in, choose one of these points. I'm going to do this. I'm going to do both of them, but I'm going to do this one first. Y minus the y coordinate, 7, equals slope, negative 11 twelfths. X minus the x coordinate, x minus a negative 3 is going to be x plus 3. That's one of them. Or the other one, y minus the negative 4. So y plus 4 is negative 11 twelfths times x minus the x coordinate, 9. Again, either one of those is correct. You don't have to write both. You just have to write one of them. If I went too fast for you on this video, please feel free to pause, rewind, and listen again. And turning the page. We are done with the video. Please go ahead and complete the 4.1 Ready, Set, Go homework. It is due on the next class day. Thank you very much. Have a nice weekend. Bye.